So when you order, especially at the local Chinese restaurant, you have three choices. And first choice is you can start with a spring roll or an egg roll. So you have two choices on that. So when you draw your tree diagram, and as I go, I'm going to do the calculation of number of ways. So that's going to be 2. And this will be times. And there are three choices for next. You can either choose noodles, steamed rice, or white rice. And you'll notice that we now have 6 choices. So this is 2 times 3. And then we have 2 choices for the soup in every case. And so that means when you draw your tree diagram, you've got a total of 12 different options when you're ordering the special. So this will be times 2, which is equal to 12. Now, next question, how many different arrangements of the word moniker begin with an I and end with a K? Well, the number of arrangements is going to be equal to, now we have, for our first letter, we have one choice. That's where we're going to put the I. Then we're going to have one choice to end. But for in the middle, we have total of 7 letters in moniker. And so since we have I at the start and K at the end, that leaves us with, for the second letter, 5 choices. The third letter, there will be 4 choices, 3 for the fourth, and 2 for the second last, and then we've only got the K to put for our last number. And so this is equal to 5 factorial, which is equal to 120. Now the number of 2-digit numbers where using 0 and 9 where the digits are not the same. So this is quite straightforward. The first thing you have to remember is we can't have a 0, because if we had a 0 first, like 0, 9, that's a 1-digit number, that's just 9. So we have 9 choices for our first number. And if the digits can't be the same, if this was a 1, then we can't use a 1, so it's got to be 9 choices for the second number. And so that's going to be 81 choices. Now, next one, number of arrangements for 4 people lining up for a group photo. And we're going to have 4 ways we can put the first person, 3 choices for the second person, 2 choices for the third, and 1 person left in the last spot. And so this is equal to 24, which is also, we could have used the permutation of 4 choose 4, which is 4 factorial over 4 minus 4 factorial. And recall that this is 4 factorial over 0 factorial, which is just 0 factorial is equal to 1. So this is equal to 4 factorial, which we have up here, 4 times 3 times 2 times 1. Now, we're going to consider 2 different cases here. How many 2-digit or 3-digit numbers using 0 to 9 are there that end in a 7? And we can repeat digits. Well, for the number of 2-digit numbers, there is going to be a total of 9 choices for the first digit. And again, we can't use 0. Times, and there is 1 choice for the last digit because it's got to end in 7. So this is equal to 9. And if you go through, it's 17, 27, 37, right up to 97. And so that will be a total of 9 two-digit numbers that end in 7. The number of three-digit numbers, well, again, we can't start with a 0, so we have 9 choices for the first number. And since we can repeat digits, we can use the number we started with. So we can have 10 numbers to choose from times 1. So this is equal to 90. So the total number of choices we have, so the number of 2 or 3 digit numbers that end in 7, this is the rule of sum. It's going to be 9 plus 90, which is 99. And again, this would be mutually exclusive events. We can't have a 2-digit number and a 3-digit number. So if it says how many 2 or 3-digit numbers, then you can find the number of 2-digit numbers and the number of 3-digit numbers, and the rule of sum tells you that you add them. Now, number 6, there's 7 books to be arranged on a shelf. How many ways can this be done? Well, this will be the permutation of 7 choose 7, which is equal to 7 factorial, which is equal to 5,040. Next one, and we've seen this type of question before. If we're going to arrange this, but the French and the English books must be together, well, we use blocking. So we're going to block this as a single unit, the French book and the English book. So we are going to then have only 6 factorial arrangements, but then the French could be on the left or the French could be on the right. So there is going to be 2 factorial ways that we could arrange the French and the English book. In other words, 2 ways we could arrange them. So 6 factorial times 2 factorial is going to be 720 times 2, which is 1,440. Now, next question. If we've got, we're going to block the French, English, math, and German books together. So we're going to treat them as one single unit. Well, now we've got 3 other books and this block book. So there are 4 factorial ways we could arrange those. Times, because now we could arrange these books, and the number of ways that you could arrange 4 objects is going to be 4 factorial. Because we have 4 choices for the book on the left. We could choose French, English, math, or German. Then for the next book over, we could choose from the other 3. So it would end up being 4 times 3 times 2 times 1, which is going to be 24 times 24, which is equal to 576. Now, if we want to know how many ways can this be done if the French and the English book must not be together, well, we calculated the number of ways, total number of arrangements. In part A. And in part B, up here, we found the number of ways we could arrange the French and the English book together. So the way we can do this is using the indirect method. It's going to be the total number of arrangements minus the number of ways, the number of arrangements, where French and English are together. and that was our answer in B. So our answer in A was 5,040 minus our answer in B was 1,440, which leaves us with then a total of 3,600. Now, if the math book must go first and the French book must be last, that's like the moniker question we were just looking at. We have one choice for our first book, because that's going to be our math book, times, and then we got 5 choices for our second book, times 4, times 3, times 2, times 1, and then times 1. So this is going to be then 5 factorial, which is 720. Sorry, 120.